So there's this idea I want to share with you. It comes from computer science, but honestly, it's completely changed how I think about solving some of the really big, messy, and, well, seemingly impossible problems in my own life. Let's explore it together. Okay, to get started, let's just try a little thought experiment. Imagine you're planning the ultimate road trip. You've got this list of cities you absolutely have to see. The goal, right? It seems simple enough. You want to visit every single city on that list, find the absolute shortest, most efficient route to save time and gas, and then, end up back where you started. You're looking for that one single perfect loop. Well, as it turns out, this little quest for the perfect path is actually a classic and famously difficult problem. In the world of computer science, this exact challenge has a name. It's called the traveling salesman problem. You can picture it like a delivery truck that has to visit a bunch of different locations from one central warehouse and then come back, all while trying to find the route with the shortest possible mileage. Okay, so let's get into this a little bit. The traveling salesman problem belongs to this special class of problems they call NP-complete. Now, that sounds super technical, I know, but the core idea is actually pretty simple. All it means is that as you add more and more cities to your road trip, the time it takes for a computer to find that single, absolute best route just explodes. For a handful of cities, sure, it's doable. But for, say, 20, 30, or 100 cities, finding the perfect solution could take the fastest computers on Earth longer than the age of the entire universe. It's just, for all practical purposes, impossible. So, if finding the perfect answer is basically impossible, what do we do? Do we just give up? Well, no. This is where we get to make this really brilliant shift in our thinking. Instead of aiming for perfect, we're going to aim for something that's provably good enough. And this is really the crucial question, isn't it? Since trying to find the absolute best path is going to take forever, what if we could find a really, really good path and find it quickly? What if we aim for a solution that's just near perfect? And that brings us to the hero of our story, the approximation algorithm. See, this is an algorithm that doesn't promise you the perfect solution. Instead, it promises two really important things. One, it will run fast, like efficiently, and two, it will give you back an answer that is guaranteed to be close to the best one. But okay, that raises a new question. If we aren't getting the perfect answer, how can we be sure that our good enough answer is actually, good? How can we trust it? Well, the answer lies in something called the approximation ratio. You can think of it like a mathematical guarantee of quality. It's a simple comparison of the cost of our good enough solution, like, say, the total mileage of our road trip, to the cost of the absolute perfect solution that we can't actually find. It gives us a hard limit on how far off our answer could possibly be. And this is where the power of that guarantee really shines. For example, if an algorithm has an approximation ratio of 1.5, it means the route it gives you is guaranteed, at worst, to be only 50% longer than the shortest possible path that exists. It might be way better than that in practice, but you know for a fact it will never be worse. We have a boundary on our own imperfection. This gives us a whole new way to think about making progress. You know that old saying, a good plan today is better than a perfect plan tomorrow? Well, this is the mathematical proof of that idea, especially when tomorrow might literally never come. It's all about making real, tangible progress right now. What's even cooler is that we can actually take this whole idea a step further. We can start to actively control the trade-off between how much time we're willing to spend and how good of an answer we get back. This is done with something called an approximation scheme. It's basically an algorithm where you don't just give it the problem, you also give it a value, they usually call it epsilon, that tells it exactly how close to perfect you need the answer to be. So the whole process looks something like this. First, you tell the computer your road trip problem. Then, you decide on your tolerance for error. Do you need an answer that's within 10% of perfect, or maybe 25% is good enough for your needs? You choose that value. And then, the algorithm gets to work and finds you a solution that is guaranteed to meet that specific level of quality. And that's really the heart of it, this incredible trade-off. If you want an answer that's ridiculously close to perfect, say within 1%, you can get it. You just have to give the algorithm a little more time to think. You are in control of that balance between speed and precision. It's just a practical path forward. So why does any of this matter to us, beyond planning road trips or directing delivery trucks? It matters because this isn't just a computing strategy. It's a life strategy. Seriously, Think about it. When you're staring down a huge research paper, is it better to spend a week trying to find the single perfect thesis statement or to just start writing with a good enough one and then refine it as you go? The same goes for planning your study schedule for finals. A good plan that you can actually start today is so much more valuable than a perfect one you're still agonizing over a week from now. This applies anywhere that the hunt for perfection just leads to paralysis. It really teaches us a powerful lesson. Sometimes the only way to make any progress at all on these seemingly impossible problems is to let go of the demand for a perfect solution. Embracing the good enough is how we solve the impossible. So, I'll just leave you with this thought to carry with you. Where in your own life are you stuck searching for that one single perfect path? And where might a guaranteed good enough answer be exactly what you need to just start moving forward? Thanks for exploring this idea with me.